question on the second statistics quiz. So what the question is asking us is scores on the Wechsler Adult Intelligence Scale, or a standard IQ test, for the 20 to 34 age group are approximately normally distributed with a mean at 110 and a standard deviation at 25. So the first step in solving any word problem is picking out what is most important. So the first thing that I noticed is that the scores in this example are approximately normally distributed, which means that you're going to get a graph that looks like your standard bell curve, very symmetric, one mound, very even. Second thing you should notice is that your mean is centered at 110. The mean is the average value of all the data points on your graph, and standard deviation is 25. So the standard deviation is a measure of basically how spread out a data set is. You could also think of this number as the square root of the variance. So if we were to go ahead and look at this on a graph, it would look something like this. We know that with an approximately normal graph, it looks just like this bell curve, and then the mean and the median are always located in the center, so I labeled that here, 110. And then the standard deviation is always taken in relation to the mean, so you see every 25 intervals is another standard deviation, so 135 for 25 above the mean, and 85 for 25 below the mean. The last basic piece of knowledge that you need to know before going on is that under this distribution curve, the entire area is equal to 1. Now knowing all this information, we should be more than ready to move on to Part A, which says, what percent of people aged 20 to 34 have IQ scores above 100? So in order to solve this, we're actually going to have to take something called a z-score, or standardized score. The equation for z-score is given here. It's your given value minus your mean divided by standard deviation. Gives you z. So if we plug in what we know, our given value, or x, will be 100 minus our mean of 110 divided by a standard deviation of 25. And if you plug this into your calculator, you should get negative 0.4. So what do we do with this negative 0.4 z-score? So if you look on the inside cover of your statistics textbook, it gives you a diagram of basically what the z-score represents. The z-score helps you figure out the area up to your given value, which in our case was 100. So what we do is we plug the 0.4 into this table, so it's right here, and we find the corresponding area, 0.3446. So if we were to look at a graph, what that is basically telling us is that the area up to our given value of 100, right in here, is equal to 0.3446. But Part A is asking for what percent of people have scores above 100, and so far we've only found the area below. But it's a really simple fix, knowing that our area under our distribution curve is equal to 1. So all we'll have to do is take our entire area, which is 1, and subtract 0.3446. This should give you an answer of 0.6554. So what that is basically saying is 0.6554 of 1, or 65.54%. And that is your final answer. 65.54% of the IQ scores are above 100. So just a quick recap of how we did this. We took the z-score of our given value, which was negative 0.4. We plugged that into the table, and we're given the area of this distribution curve from 0 to 100, our given value. We took that area and subtracted it from the total area, which is 1, which gave us 0.6554, and we turned that into a percent, and that was our answer. tackled part A and it's time to move on to part B. What I'm going to do is I'm going to take the most important information we found on the basic question and just put it on a little guide right here so we have more space to work. Alright, so part B asks us what percent of scores are above 150. So we're going to use a very similar process that we used in part A, and we're going to take the z-score again. So we take our given value, 150, subtract the mean, 110, and then divide by the standard deviation of 25. This gives us a z-score of 1.6. We plug this 1.6 into our table. Go ahead and look for it. It's right here. The corresponding value is 0.9452. If we go ahead and look at that on our graph again, we'll see that the area all the way up to 150 is equal to 0.9452. Again, this area is not what we're looking for because we want above 150, so we'll have to do the same thing we did in the last problem and subtract this from our entire area under the curve, which we should remember to be 1. So if we do that, we have 1 minus 0.9452. That gives us 0.0548. So, which is basically saying 0.0548 of 1, or 5.48%. And that again is your final answer. So 5.48% of scores are above 150. That tackles part B, and now we're on to part C. C asks how high an IQ scores need to be in the highest 25%, or you can see I can rewrote it to say the 75th percentile, 75%, it's the same thing. Another thing you should notice about part C is that it is actually giving us a percent and not a given value. So for this problem, we'll be working backwards from what we've been doing in part A and B. The first thing to do in order to work backwards is change this 75% into a proportion. So if we go ahead and do that, it would look like this. 75% of 1 is saying the same thing as 0.75. So we'll go ahead and find 0.75 on our chart and find the corresponding z-score that goes with it. So if we go ahead and swing right over there, we can see that the closest proportion to 0.75 is 0.7486, which lies at 0.67. Now that we know what our z-score is equal to, 0.67, we can go ahead and plug that back into the equation that we used in part A and B. So we don't know x this time, but we still know the mean to be 110, and the standard deviation is still 25. And then we'll plug in the z-score, which we know, 0.67. And from there, we'll times both sides by 25. Giving us x minus 110 equals 16.75. And then we'll add 110 to both sides. And that gives us x equals 126.75. And that is your final answer. So in order to score on the IQ test in the highest 25%, you must have a score of at least 126.75, or if you round to the nearest whole number, 127. Just a quick recap of how we did that: we changed a percent into a proportion, plugged that into our table, and then got the corresponding z-score, plugged that into the equation we used in part A and B, and figured out our x value. And voila. That just about wraps up question number 1.